3.
The distinction of past and future.
Now, it's obvious to everybody that the phenomena of the world are evidently irreversible. By that I mean things happen that don't happen the other way. You drop a cup and it breaks, and you can sit there a long time waiting for the pieces to come together to come back into your hand. If you watch the waves breaking at the sea, you stand there and wait for the great moment when the foam collects together, rises up out of the sea, and falls back further out from the shore. Would be very pretty. As a matter of fact, the demonstration of this in such lectures is usually made by having a section of moving picture in which you take a number of phenomena and running the thing backwards and then see all the laughter. The laughter just means this ain't going to happen in the real world. But actually, that's a kind of a weak way to put something which is so obvious and deep as the difference between the past and the future. Because even without an experiment, our very experiences inside are completely different for past and future. We remember the past, we don't remember the future. We have a different kind of awareness about what might happen than we have of what most likely has happened. The past and future look completely different psychologically and so forth. And the questions of memory, of apparent freedom of will, in the sense that we feel that we can do something to affect the future, but none of us, or very few of us, believe that there's anything you can do to affect the past. And remorse and regret and hope and so forth are all words which distinguish perfectly obviously the past and the future. Now, if the world of nature is made of atoms, and we too are made of atoms that obey physical laws, there's obvious distinction between what happened, the past and the future, and this obvious irreversibility of all phenomena, you would think would most likely have obviously its interpretation in that some laws, some of the motion laws of the atoms are going one way, that the atom laws are not such that they can go either way, that there's somewhere in the works some kind of a principle that wuxels only make wuxels and never vice versa, and so the world is turning from wuxely character to wuxely character all the time. And that this one-way business of the interactions of things is the thing that makes the whole phenomena of the world seem to go one way. And yet we haven't found it yet. That is, in all the laws of physics that we've found so far, there doesn't seem to be any distinction of the past and the future. That the moving picture should work the same way going both ways, and the physicist who looks at it should not laugh. Details now to be explained. Let us take the law of gravitation as our standard example. If I have a sun and a planet that I started off in some direction going around to here, and then take a moving picture of this, say it gets to here. Now take a moving picture of this backwards. Take a moving picture of it, and run the movie backwards and look at it. What happens? Planet goes around the sun in an ellipse. The speed of this way, of course. Starts here, goes to here, keeps on going around. Goes in an ellipse. The speed of the planet is such that the area swept out by the radius is always the same in equal time. Just does exactly the way it ought to do. It's perfectly satisfactory. It cannot be distinguished from the one going the other way. So the law of gravitation is of such a kind that it doesn't make any difference. If you show the phenomenon running, any phenomenon involving just gravitation running backwards on a film, it'll look perfectly satisfactory. Put it precisely more this way. If at a given instant the particle moving this way, if all the particles in a more complicated situation would have every one of their speeds reversed suddenly, then the thing will just unwind through all the things that it wound up into. That is, if you have a lot of particles doing this, then you suddenly reverse the speeds, they will completely undo what they did before. Now this is in the laws of gravitation, which say that the velocity changes as a result of the forces and so on. If I reverse the time, the forces are not changed, and so the changes in velocity are not altered at corresponding distances. And so each velocity then has its succession of alterations made in exactly the reverse way that they were made when it went out before, and it's easy to prove that the law of gravitation is time reversible. The law of electricity and magnetism, time reversible. The laws of nuclear interaction, time reversible as far as we can tell. The laws of beta decay that we talked about at a previous time, also time reversible. The difficulty of the experiments of a few months ago, which indicate that there's something the matter with some unknown about the law, suggests the possibility that in fact it may not be also time reversible, but we shall see. But at least the following is true. This beta decay that we're talking about, which may not be time reversible, but I don't know, is a very important phenomenon for most ordinary circumstances. The possibility of my talking to you does not depend on that happening. It does depend on chemical interactions. It depends on electrical forces. It doesn't actually depend much on nuclear forces at the moment, but it depends also on gravitation. But I am one-sided. I speak and the voice goes out into the air and doesn't come sucking back into my mouth when I open it. And this irreversibility cannot be hung on the phenomena of beta decay. In other words, we believe that there are in the world most of the ordinary phenomena which are produced by atomic motions which are according to laws which couldn't be completely reversed. So we have to look some more to find the explanation. If we look at this more carefully and a planet's moving around the sun more carefully, you soon find that it isn't quite right. For example, the Earth's rotation on its axis is slightly slowing down. That's due to tidal friction. And you see that friction is something which is obviously irreversible. If I took a heavy weight on the floor here and pushed it, it would slide and stop. If I stand and wait for it, it doesn't suddenly start up and speed up and come into my hand. So a frictional effect seems to be irreversible. But a frictional effect, as we discussed at another time, is the result of enormous complexity of the interactions of the block with the wood, the jiggling of the atoms inside, that the organized motion of the wood, of the block, is changed into disorganized, irregular wiggle waggles of the atoms in the wood. So that therefore we should look at the thing more closely. As a matter of fact, we have here the clue to the apparent irreversibility. I take a simple example of, for example, if we have blue water, say ink, and white water, that's water without ink, in a tank with a little separation, and pull out the separation very delicately, then it starts separate, blue on one side, white on the other side. Wait a while. Gradually the blue mixes up with the white, and after a while the water is blue. I mean, it's sort of 50-50, a color uniformly distributed throughout. Now if we wait for a long time and watch this for a long time, it does not by itself separate. Or you can do something. You can get the blue separated again. You can evaporate the water and condense it somewhere else and